Imagine a basketball, you throw it at a wall, it bounces back, right? That's common sense, the world according to Isaac Newton. Now imagine that basketball is actually a tiny, tiny particle, smaller than an atom. Sometimes, surprisingly, it doesn't bounce back. It passes right through the wall. Welcome to the strange world of quantum tunneling. In the quantum realm, the rules of the game are different. Particles don't behave like solid objects, they act more like waves, spread out and blurry. This wave-like nature allows them to do things that seem impossible in our everyday world. One of these things is tunneling. Think of it like digging a tunnel. If you hit a solid wall, you can't just walk through it. You'd have to dig a tunnel to get to the other side. Quantum particles do something similar. They don't break the wall down. Instead, their wave-like nature gives them a chance to tunnel through the barrier. This isn't just some abstract theory. Quantum tunneling is happening all around us, even inside you right now. It's the reason our sun shines and the basis for technologies we rely on every day. So buckle up as we journey into the subatomic world to explore the mysteries and possibilities of quantum tunneling. In the macroscopic world, we're used to objects having definite positions and movements. A ball thrown in the air follows a predictable path. But in the quantum world, things are fuzzier. Particles are governed by probabilities, not certainties. The wall represents an energy barrier. Classically, the particle needs enough energy to go over it, but quantum mechanics says there's a chance the particle's wave function can extend through the barrier. This means there's a chance the particle can suddenly find itself on the other side, even without enough energy to overcome the barrier. Think of it like rolling a ball up a hill. Sometimes it might just magically appear on the other side, even if it didn't have enough speed to make it over the top. The thicker the wall, the less likely it is to tunnel. It's like digging a tunnel. A short tunnel is easier to dig than a long one. This ability to tunnel through energy barriers has profound implications. It's not just a theoretical quirk, it's fundamental to the workings of our universe, from the heart of stars to the very air we breathe. Our sun, the lifeblood of our solar system, is a giant fusion reactor. It's constantly fusing hydrogen atoms into helium, releasing enormous amounts of energy in the process. But there's a problem. The protons, the positively charged particles in the hydrogen atoms, repel each other. They have the same charge, and like charges repel. The core of the sun is incredibly dense and hot, but even this isn't enough to overcome the electrostatic repulsion and force the protons close enough to fuse. This is where quantum tunneling comes in. The protons don't need to climb the entire energy hill. Thanks to their wave-like nature, there's a chance they can tunnel through the electrostatic barrier and fuse together. This tunneling process is rare, but it happens often enough in the sun's core to sustain the fusion reaction and provide the light and warmth we depend on. Quantum tunneling isn't just happening in stars, it's also crucial for many chemical reactions here on Earth and in the vastness of space. It's a fundamental process that underpins the very fabric of our universe. Quantum tunneling isn't just a cosmic curiosity, it's also the driving force behind many technologies we rely on every day. Take transistors, for example. These tiny devices, the building blocks of computers and smartphones, rely on quantum tunneling to control the flow of electrons. In a transistor, a thin, insulating layer acts as a barrier. By applying a small voltage, we can control the probability of electrons tunneling through this barrier, switching the transistor on or off. Without quantum tunneling, our electronic devices would be vastly larger and less efficient. Quantum tunneling is also used in scanning tunneling microscopes, STMs. These incredible devices allow us to see individual atoms by exploiting the tunneling current between a sharp tip and a sample surface. The STM is a testament to our ability to harness and exploit the strangeness of the quantum world. Section 5. Beam me up, not so fast. The limits of quantum tunneling. The idea of teleporting ourselves instantly from one location to another is a staple of science fiction. And while quantum tunneling might seem like a possible route to achieving this dream, the reality is far more complicated. Yes, particles can tunnel through barriers, but there are several fundamental limitations that make human teleportation improbable, bordering on impossible. Firstly, quantum tunneling is a probabilistic phenomenon. We can calculate the probability of a particle tunneling, but we can't predict when or if it will happen. For a complex object like a human being, the number of particles involved is astronomical. The probability of all of them tunneling simultaneously and arriving at the destination intact is infinitesimally small. Secondly, teleportation would require more than just moving matter. We'd also need to transmit the information about the quantum state of every single particle in the body. This information is vast and incredibly delicate. Even the tiniest disturbance could disrupt the teleportation process, leading to catastrophic results. Section 6. Quantum leaps in technology, the future of tunneling. While human teleportation remains a distant dream, quantum tunneling continues to fuel exciting technological advancements. Researchers are exploring ways to harness tunneling for even faster and more powerful computers. Quantum computers could revolutionize fields like medicine, materials science, and artificial intelligence. Another promising area is quantum communication. Tunneling could enable the development of ultra-secure communication channels, impervious to eavesdropping. Imagine a world where sensitive information from bank transactions to government secrets could be transmitted with absolute security. Quantum tunneling is also key to developing new sensors and imaging devices with unprecedented sensitivity. These devices could have applications in medical diagnostics, environmental monitoring, and even space exploration. Section 7. A universe of possibilities. Quantum tunneling and the future of exploration. Quantum tunneling plays a crucial role in our understanding of the universe. It helps explain how stars ignite and how elements are formed. But its implications for the future of space exploration are equally profound. As we venture further into the cosmos, we might encounter environments where quantum effects become even more dominant. Imagine spacecraft propelled by exotic engines that exploit quantum tunneling to achieve incredible speeds or navigate through seemingly impassable barriers. Or perhaps we could develop communication systems that utilize tunneling to send and receive information across vast interstellar distances instantaneously. While these ideas might seem like science fiction today, so did the concept of landing on the moon just a few generations ago. As we delve deeper into the mysteries of the quantum world, who knows what incredible technologies we might unlock? Section 8. The Final Frontier. Will we ever teleport? So, will we ever be able to teleport ourselves across vast distances, Star Trek style? While quantum tunneling is a real and fascinating phenomenon, it's unlikely to be the key to human teleportation, at least not in the way we typically imagine it. The challenges of simultaneously tunneling every particle in a human body, while preserving their quantum states and reassembling them perfectly at the destination, are simply too immense to overcome with our current understanding of physics. However, this doesn't mean we should abandon all hope of teleportation. The universe is full of surprises, and our understanding of physics is constantly evolving. Perhaps there are other yet-to-be-discovered principles that could make teleportation possible in ways we can't even fathom right now. The quest to understand and control the quantum world is still in its infancy. As we continue to explore the subatomic realm, we might uncover new insights that could revolutionize our understanding of teleportation and other seemingly impossible technologies. Section 9. Beyond the Horizon, the enduring allure of quantum possibilities. Quantum tunneling is a testament to the strangeness and wonder of the quantum world. It's a phenomenon that defies our everyday intuition, but plays a fundamental role in the workings of the universe and the technologies we rely on. While human teleportation might remain a distant dream, the exploration of quantum tunneling continues to open up exciting possibilities for the future. From faster computers and ultra-secure communication, to new medical technologies, and even the potential for revolutionary space travel, the applications of quantum tunneling are vast and still largely unexplored. As we continue to probe the mysteries of the quantum realm, we can only imagine what incredible discoveries await us. One thing is certain: the future of technology, and perhaps even our understanding of the universe itself, will be deeply intertwined with our ability to harness the power of quantum tunneling. So the next time you see a beam of sunlight or use your smartphone, take a moment to appreciate the invisible quantum world and the mind-boggling phenomenon of tunneling that makes it all possible.